Okay, so for the second part here, what we're going to look at is transformations on that tangent graph. So the first part we did just some general graphing of the tangent function. Now we're going to do what happens when you throw in an a value or a b value or the h or the k. So this, you have the same basic steps. It's just going to be doing those shifts, that vertical displacement, and then the phase shift either left or right. And then on top of that, you'll have either your amplitude changing or your period changing, or maybe a combination of both. So the first one says, graph the function y is equal to tan x minus 1 over 2 cycles. Determine the domain, range, and equations of the asymptotes. Okay. So the first thing we want to do is same thing as we did in the sine and cos. We want to do those transformations first, where we are moving our vertical displacement, or putting in our vertical displacement and our phase shifts. So if we take a look at this one, you don't have anything in the bracket. Our general form would be like this, right? A tan b x minus h plus k. And they might use different letters in the textbook. I didn't even look to see, but basically the same thing. Our phase shift is going to come from inside our bracket, just like it did with the sine and cos, and our vertical displacement is going to come with that k value. So this one, we have a b is equal to 1, our a is equal to 1, our h is equal to 0, and our k is equal to -1. So all this means is that we're going to have that vertical displacement. Oops, that should be displacement, so it's going down 1. Okay, so on our graph here, this is our y, this is our theta. We're going to put our new vertical axis, or horizontal axis. So it was here, it's now going to move down 1. The second thing that you're going to do then is to put in those asymptotes. So what we want to do for this, because we know since our b is equal to 1, the period for this is just going to be pi. Remember, for tangent, it's different than for sine and cos. This tangent graph will repeat itself every pi times. For sine and cos, it was every 2 pi when you had a b of 1, so on the normal. So I know that this is going to be a pi. So what I want to do, because we're always working with our key points are in, we divided into 4 for our key points. So what we want to do for this then is to let every 4 spaces equal pi. Okay? So when we're figuring out our horizontal axis, we're going to let every 4 spaces equal pi. So 1, 2, 3, 4, this is pi, this would be 2 pi, this would be 3 pi. Going on the negative, we'd have negative pi, negative 2 pi, and negative 3 pi. So now we want to do our asymptotes. So number 1 was to do our transformations. Can't spell today. Transformations. Number 2 then is we want to do our asymptotes. So we know from the work that we did in that first section that every half a cycle, or every, in this case, half of a cycle is every pi over 2, we're going to have that asymptote. So if I'm going to repeat this function every pi. Halfway through is going to be my pi over 2. So this one asymptote is at pi over 2. Remember, it's the odd, 3 pi over 2, and then 5 pi over 2. And I could continue this onto the negative. Okay, so that means now I can start doing my plotting. So what you're going to do when you do your plotting is you're going to do your basic points of your tangent graph. Now, because this one doesn't have an A value or a B value that's going to be affecting those, our amplitude's still going to be the same, so we're still going to be doing the same plotting when it's pi over 4 or a multiple of that pi over 4, then we're going to have a 0. Sorry, pi over 4 is 1. When we start at 0, the 0 is going to have a 0. Pi over 4 will be at 1. 3 pi over 4 then would be at negative 1, and then pi would be back at 0, and so on. So this is, I'm just getting those values, if you can't remember it, based on the unit circle, and where tangent is equal to 1 and 0, okay? And then also based on the pi over 4 or our 45 degree, and then the 30, 60, 90. So we have all those values in the chart. I'm not going to go through all of them here again. So I plot my points then. So at 0, and my new 0, 0 is right here. I'm right on that axis. And then at the next one, when I was at pi over 4, my value was 1 up. And then I could do the other ones. I could do the in between the pi over 4 and pi over 2 and plot those points. But you have the basic point there. So I know that this one is going to go up. My next 0 occurred at pi. Do you remember it was every multiple of pi was when we had a 0? So this one's going to be here. Halfway between my pi and my 3 pi over 2 is where I'm going to have that. So that would be at 3 pi. So that's not 3 pi over 4. It'll be 5 pi over 4, which would be here. That's where I would have my 1. Halfway between pi over 2 and pi over and pi, which would be 3 pi over 4, that's where it would be the negative value. So this plot is going up, and at this point here, this part of the graph, it's going down. So then my next one over, I would have my 0 is at the 2 pi. Halfway in between my asymptote and the 0 is where I have the negative. Halfway between the 0 and the next asymptote is where I have the positive one. And then it would continue on down the graph. Okay, so I've actually done this for 2.5 cycles. What I should have done over 2 cycles starting at here, I should have just done the top, this full one, and then the bottom half of this one. So this part here was actually giving me an extra half a cycle. So my domain now. Domain is the set of values for x are going to be all real numbers, except x cannot equal wherever my asymptotes were. And my asymptotes were at the multiple of pi over, the odd multiples of pi over 2. So that was pi over 2 times odd multiple is 2n plus 1. My range, set of values for y, are all real numbers again. It's going to go up and down forever. My equation of the asymptote. So these dotted lines occurred when x was at those odd multiples of pi over 2. So instead of putting that equal to sign there, you just drop it off, and you're done. So the next one says, to draw the graph of the function y is equal to tan x plus pi over 2 over 2 cycles. So in this one here, my a is a 1, so I'm not changing my amplitude. I'm still going to be at 1 and negative 1, going up 1, down 1 from my my horizontal axis. My b value is 1, so that means that my period is still going to be at pi. But I have an h equal to h is equal to, well, it'd be a negative pi over 2. If I pull that out of there, I take the opposite sign. So that means I'm going to have a phase shift of pi over 2. So my phase shift is pi over 2 to the left. And then I don't have a k value is equal to 0, so I don't have a vertical displacement. So the first thing I want to do is take a look at, okay, what is my transformation? So in this case, your transformation is that pi over 2, which is my phase shift to the left. Okay, so now what I need to do is I have to decide, okay, what am I going to use as my tick points on here, if you want to call that? So how am I going to set my grid here? Well, I'm going to keep my y so that every mark on there is 1 unit, and I'm going to have every 4 units again equal to pi. And you don't have to number these. This is just my numbering for you to see the steps. So because my period is still 1, I haven't changed anything there. That means that I'm going to still have my asymptotes are going to be at every pi over 2. Should have said every pi over 2. So now I can draw those in. So I'm going to do, so this is pi, this is 2 pi, this is 3 pi. Now I need to do my phase shift. So a phase shift of pi over 2 means that instead of starting here at the 0, this is going to be my new starting point right there. So my asymptotes here, sorry. That's, yeah, I did a purple line there, so that's okay. So my asymptotes now are going to be, oh, sorry, I went pi, that's why I'm confused here. This should have been pi over 2 to the left. I went pi over 2 to the right. But this isn't working. So this should have been right here, pi over 2 to the left. I'm just going to label this. So this is negative pi and negative 2 pi. Okay. So now that means that I have to put my asymptotes in. So my asymptotes are still at every pi units. So I'm going to have an asymptote here. I'm going to have an asymptote here. I'm going to have an asymptote there. And if I go to the negative, I'm going to have an asymptote there and there. So now when I go to draw this in, I start at my 0, 0, so my new 0, 0 is here. So at this point here, it's going to be 0. And then I'm going to go halfway in between that and my asymptote is going to be my 1 value. So this graph will go up this way. And halfway between, it's going to go to the negative. So it goes there. So the same thing then going this way, my pi over 2 is going to be my 0. and this. Oops, that should have gone through the 1. This will go through the 1, and it'll look like that. When it's asking you to do this over 2 cycles, you always want to start, and because I like to draw these, I guess, I always do both sides, but I technically, because it's asking for 2 cycles, it's asking you to start from your origin and then do 2 cycles over. So I don't need to include this in the drawing. It's not wrong. This, just because it specifically says 2 cycles, then I need to continue it there. So then the last one would be this half of it. So I've got 2 complete cycles. They're not 2 cycles that are joined in a row, but it's 2 complete cycles starting at that 0. So I finished my transformations. I've got my asymptotes in there. I put in my key points and plotted them. So now I can do my domain. Now this one, the domain is going to be a little bit different. My domain is always coming from that x plus x, or x plus h, or x minus h, whatever you put it in here. So it's always coming from in here. So that's what we want to do to solve this. So I have my x plus pi over 2 because of my transformation. Before I had x not equal to. Well, now this has replaced my x. X plus pi over 2 has replaced my x. So I put that not equal to. What is my general formula for that? Well, it's normally for the domain, we use that pi over 2 times 2n plus 1. So what we want to do then is we need to solve for x. So in order to solve from x, we're going to have to do some order of operations to do some solving. So the first thing that we're going to look at doing is I need to multiply this through, this pi over 2 through, so I can get my solution. So this becomes 2n pi over 2 plus pi over 2. So these 2's will cancel, and I have n pi plus pi over 2. Well, now I can subtract this pi over 2 from here, and this one from here. So in essence, these 2 cancel, and those 2 cancel. So what I'm left with is x is not equal to n pi. So that is what your domain then is going to be. The set of values for x, it's all real numbers except x cannot equal to n pi. So if I take a look at this one, n pi should mean that's where my asymptotes are. And if I look on here, because of my phase shift over, it is. My asymptotes are at pi, 2 pi, they'd be at 3 pi. Going this way, they'd be at negative pi, negative 2 pi, and so on. If you remember in your original, when there wasn't any phase shifts going on, they were at every odd pi. Okay, every odd pi over 2. So our asymptotes we're at 90, 270, 450, and so on. Because of our phase shift, those asymptotes have moved. Okay, so that's what the phase shift did to our asymptotes. So the thing to keep in mind when you're doing that is that when you do your phase shift, wherever your starting point is, your asymptote always has to be halfway in between your cycle. So I needed my cycle still to be a full pi for this one, so that's where this happened at the pi's, because everything moved over a pi over 2, so then that means my asymptote had to move over a pi over 2. So instead of being here at pi over 2, it had to shift a pi over 2 over because of that phase shift. Okay, the next one says graph the function of y equals 3 tan x over 2 cycles. So if I take a look at this question, y is equal to 3 tangent of x, my a is equal to 3, b is equal to 1, h is equal to 0, k is equal to 0. So what that is saying is, I don't have any for my transformations here. I don't have any phase shift or vertical displacement because h and k were 0. My b is equal to 1, so I know that my period is still going to be over pi, but now my amplitude is equal to 3. So that means that my points are going to change from being at wherever they were equal to 1, they're now going to be equal at 3. So my asymptotes, if I put those in, because the period didn't change, it hasn't shifted, then my asymptotes are still going to be the same thing. They're going to be at that pi over 2, 3 pi over 2, 5 pi over 2, and so on. So I can draw those in. Because I'm still working at a period of pi, I'm going to say that every 4 ticks on here is the equivalent of pi. And that just makes it nice and easy to divide this up into those four sections for your other key points that we're looking at. So my asymptotes then are at every pi over 2. So I have one asymptote is here. The next one's going to be halfway in between there, and then the next one will be there. So now my amplitude, to take care of that. In my original, when I had x, or theta, whatever you want to call it, and then my y, when x was 0, this was 0. When x, or my theta, was pi over 4, this equaled 1. When it was 3 pi over 4, it was negative 1. When it was pi, it was 0. 5 pi over 4, and these might not be in perfect numerical order, but that's okay. It was 1. 7 pi over 4, there's that negative 1, and then 2 pi put me back at 0. So if I did my transformation where my a, so my ay value, so now this is going to be 3 times y. So this one will stay at 0, this one will go to 3, this goes to negative 3, that stays 0, 3, negative 3, and 0. So all I did was multiply my y values by 3. So I can plot those. So at 0, it's still 0. At pi over 4, which is here, it's going to be up at 3 instead of at 1. So it'll be at 1, 2, 3 here. And then if I continued doing 3 pi over 2 and so on, you would get your other points. But we know it's going to get closer and closer to that asymptote, but not touch it. So if this is pi over 2, 3 pi over 4, which is right there, it's negative 1, transformed down to negative 3. At pi, it's 0. At 5 pi over 4, which would be just right past here, it's going to be 5 pi over 4 is positive 3. So you can see the pattern that's happening here. So these are, what's happening too is that these are starting to straighten out, if you want to think of it that way. When we did it before, I'll just do it in another color. Our normal one would have been going here and then here, so we had more of a curve going. Now it's straightening it out. So then my next one here, so I did 7 pi over 4, which would be right here. At 7 pi over 4, it was at negative 1, so that means it's going to be down at negative 3, and then at 2 pi, it's back at 0. So it's going this way. So now I've done 2 complete cycles. I've got 2 on the up, or 2 on the positive, if you want to think that way, 2 on the negative. So that's done for my graph of it. If I want to do the domain and the range, domain, same thing, I take a look at what is my x is just an x, so that means it's going to be the normal. X is an element of real numbers, except x cannot be equal to pi over 2 times 2n plus 1. So it can't be that odd multiple of pi over 2. And we should actually be including here that n is an element of integers. We're only using positive and negative numbers. We're not using any rational numbers in there. Your range, y is an element of real numbers. Equation of the asymptote is, again, just this with an equal to. X is equal to pi over 2 times 2n plus 1. Okay, so we've done the graphing for this. Now what you can do is you can take and do describe the transformations that are going to happen and find the period of a function without drawing it. So if y is equal to tan x, that gives us a normal period. Our b value is equal to 1. That means that our period for a tangent is going to be pi. So the same thing as we did before with sine and cos. To find our period, it's just going to be pi over the absolute value of b. So in this one, y is equal to tangent of 6x, b is equal to 6, so that means your period is going to be pi over 6. For the next one, our b is equal to 1/4, so that means that your period is going to be pi over, 1/4, which is the same thing as saying pi times 4, so it's a 4 pi. Now that matters for the next graphs that we're going to be doing. So we have y is equal to tangent of 2x, and we want to graph that over 2 cycles. So same thing then we want to do, so we have 2 positive sides to the curve and 2 negative sides of the curve starting at our origin. So in this one, I can move this up a little bit. Our b is equal to 2, so then that means that the period is equal to pi over 2, or pi over b. So what we want to do then when we're trying to figure out, okay, when our other graphs, when our period was just a normal pi, we said every 4 ticks on here is going to equal pi over 2, or pi. Because our period is changed to a pi over 2, we're going to have, for this graph, to make it easier to do, we're going to have 4 spaces is equal to pi over 2. So every 4 spaces is pi over 2, instead of every 4 spaces is pi. So that means this would be pi over 2, this would be pi, I want to get my, yeah, and that would be pi. So pi over 2, if we think of this in quarters, is going to be the same as 2 pi over 4, and pi, of course, is 4 pi over 4. So if this is 2 pi over 4, halfway between there is going to be pi over 2, and then halfway between pi over 2 and pi, so halfway between 2 pi over 4 and 4 pi over 4 is going to be 3 pi over 4. So that should be a pi over 4 there. So I have pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. So now to do your asymptotes. Asymptotes are always halfway every half a period. So if my period is happening here at pi over 2, halfway between is going to be pi over 4. So my next one was between pi over 2, and then the next cycle would be completed by pi. So then that means halfway between is going to be at 3 pi over 4. Okay, so my asymptotes then are at pi over 4. The next one will be plus pi over 2. So that's like adding 2 pi over 4, so that's where that 3 pi over 4 comes in. And then the next one, if I added another pi over 2, then that would be at 5 pi over 4, and you can see how it would continue with your asymptotes. So asymptotes have moved because of that period changing. They're still halfway in the cycle, but because the cycle has changed, that means that where the placement of the asymptotes has to change. So once you have determined where the asymptotes are, then you plot those base points. So it's still going to be the same. At 0, 0, I'm going to have, or at 0, it's still going to be 0. Halfway in between there, then, halfway between 0 and pi over 4, which would be pi over 8, I'm going to be at 1. And then it would continue to get closer as the value got higher. So at pi over 2 is when I'd have my next 0, so it's halfway in between the period. And that means halfway between my asymptote and that 0, I'm going to have a negative value. So if this is pi over 8, this is 2 pi over 8, that would be 3 pi over 8. And then going the other way, I'd have 0, and then going up. Oops. So you can see right now, I've got 1.5 cycles, so I have to do my last cycle. So at pi, it's going to be 0. So that means halfway between, it's going to be, oops, I forgot my dots there. It's going to be negative 1. Okay, to find the domain, my x has been replaced by 2 tan x. So my domain is going to be 2x is not equal to pi over 2 times 2n plus 1. So the first thing I want to do is I want to get rid of my denominator of a 2, and it's just a matter of order of operations to solve for x. So if I multiply everything here through by 2, 2 times 2x is 4x. Pi over 2 times 2 is just going to be pi, and then 2n plus 1. Okay, so if I want my x by itself, I have to divide by 4. So x is not equal to pi over 4 times 2n plus 1. And depending on the textbook, they sometimes write this differently. Sometimes they'll multiply all this out and they'll say pi n plus pi 4, or they'll just multiply it through and break it up. This is the simplest way to write it. You can just leave it like that. So if you want to check, what this is saying is x cannot have a value at every odd multiple. 2n plus 1 means odd multiple of pi over 4. So if I look at this, I had an asymptote at pi over 4, I had an asymptote at 3 pi over 4, and then my next one would have been 5 pi over 4 if I had continued. So my domain is x is an element of real numbers except at that x cannot equal pi over 4 times 2n plus 1, and is an element of integers. My range then, y is an element of real numbers. Equation of the asymptote, x is equal to pi over 4 times 2n plus 1. Okay, now we want to graph the function of x over 4, tangent of x over 4, find the domain, range, and the equation of the asymptote. So same thing, we go through the same. A is equal to 1, b is equal to 1/4, h is 0, k is 0. So if b is equal to 1/4, then I know my period is equal to pi divided by 1/4, so it equals 4 pi. So that means for this one, every 4 spaces is going to be 4 pi. So this is 4 pi, this is 8 pi, and then this would be 12 pi if we needed to go that far. So the same thing then, my asymptotes are every half cycle. So that means if my cycle is complete at 4 pi, then I have an asymptote at 2 pi, and then I'd have an asymptote at a full cycle after that, so that'll be 6 pi, and then a full cycle after that would be 10 pi, so I'm just adding 4 pi every time. So just like in the last one, I added a pi over 2. This one, because my cycle was 4 pi, I have to add 4 pi every time. So at every odd multiple of 2 pi, I'm going to have my asymptote. So now I can plot my points because nothing changed with my amplitude. Then that means at 0 it's going to be 0, halfway in between. So if this was at 2 pi, at pi it's going to be at 1. So halfway between the cycle it's 0, halfway between the asymptote and my 0 it's at -1, and then +1 here. 8 pi, it's at 0. Excuse me. At 7 pi here, it's going to be -1. So I've now completed 2 cycles. It's done. I don't have to do the rest of it, but I could if I wanted to. So my domain, I need to solve it. So my x got replaced by x over 4. So to find it, I go x over 4 is not equal to pi over 2 times 2n plus 1. So I want to get rid of my denominator. So I have to think of, okay, what's my lowest common multiple of 4 and 2? 4. So I multiply everything through by 4. So this becomes x is not equal to 2 pi times 2n plus 1. X is by itself, I'm done. And if you remember when I was figuring out my asymptotes here, that's what I said. It's every odd multiple of 2 pi. So 1 times 2 pi is 2 pi, 3 times 2 pi is 6 pi, 5 times 2 pi is 10 pi, and so on. So that means my domain is x is an element of real numbers, except x cannot equal 2 pi times 2n plus 1, and n is an element of integers. Range, everything. Equation of the asymptotes. Drop off that equal sign because it actually happened at every odd 2 pi, and you're done. Okay, the next part asks you to find the domain, range, and the equation of the asymptotes without graphing this. So I'm going to do the exact same steps as I did in the others after I graphed them. So we always take a look at, okay, what was x replaced with to find our domain? So for our domain, I do x plus pi over 6 is not equal to pi over 2 times 2n plus 1. Okay, so the same thing, I need to get rid of my denominator, so my lowest common multiple of 6 and 2 is 6, so I multiply everything by 6. So I have 6x plus pi is equal to 3 pi times 2n plus 1. So I can't do any subtracting because this is a plus pi and this is being multiplied. So I need to multiply through there. So I have 3 pi times 2n is going to give me a 6 pi n, and then 3 pi times 1 is just 3 pi. So now I can move that pi over. I have 6x, oops, those should be not equal to, is not equal to 6 pi n plus 2 pi. So now I will need to divide through by my 6. So I have x is not equal to 6 pi n plus 2 pi, all over 6. I could leave it like that, or I could do a reduction here. I could write this as if I divide by 2 into each of my numbers here, I would have 3 pi n plus pi all over 3. Or if I wanted to separate that, I could say 6 pi n divided by 6 is just pi n, plus 2 pi divided by 6 reduces to pi over 3. Same difference. So you just need to write whichever one makes the most sense to you. So then your range hasn't changed. Y is an element of real numbers. Equation of asymptotes is x is equal to 3 pi n plus pi over 3. So determine the domain in the equation of asymptotes for the following. So for these next ones, because we know the range is always the same, we're going to leave it. So for my domain, I always look at what was my x switched out for. So it was x over 8. So x over 8 is not equal to pi over 2 times 2n plus 1. Okay, need to get rid of this 8 down here, so I'm going to multiply everything through by 8. So I have x is not equal to 4 pi times 2n plus 1. And if you're wondering how I got that 4 pi from there, if I did pi over 2 times 8, that's like saying 8 pi over 2, which is 4 pi. So the equation of the asymptotes then is x is equal to 4 pi times 2n plus 1. So every odd interval of 4 pi. Okay, this next one is a little bit tricky. Because we have this 3 being multiplied in front of here, that b value, we have to take that with us when we are multiplying, or when we're trying to find our domain. So our domain is actually 3x minus pi over 2, or if we were to multiply this through, it would be 3x minus 3 pi over 2, and then that's not equal to our pi over 2 times 2n plus 1. So I need to get rid of my denominator here. I have a denominator of 2, so I'm going to multiply everything by 2. So 3x times 2 is 6x. 3 pi over 2 times 2 is just minus 3 pi. Pi over 2 times 2 is pi, and then 2n plus 1. So I need to do the same thing as I did in a previous one. I can't do any collecting or reducing here because this is being multiplied. So I'm going to do 6x minus 3 pi is not equal to 2 pi n plus pi. Move this over, so I add 3 pi. So I have 6x is not equal to 2 pi n plus 4 pi divided by 6. I'm just going to finish it up here. X is not equal to 2 pi n over 4 pi over 6, so I can reduce all of that by 2, so it'd be pi n plus 2 pi all over 3. So your equation of your asymptote then is just x is equal to pi n plus 2 pi over 3. This can also be rewritten. If I GCF'd a pi, I could have pi n plus 2 over 3. So again, it doesn't matter how you write it, just as long as you've simplified it correctly. Okay, last one on this page. 2x minus pi over 3 is what x was substituted for. So 2x minus pi over 3 is not equal to pi over 2 times 2n plus 1. So I have to get rid of my denominators. Lowest common multiple is a 6. I have 12x minus pi over 3 times 6 is going to give me a 2 pi. Pi over 2 times 6 is a 3 pi times 2n plus 1. I solve. 12x minus 2 pi is not equal to 6 pi n plus 3 pi. Move my 2 pi over. So I have 12x is not equal to 6 pi n plus 5 pi. Divide by 12. So x is not equal to 6 pi n plus 5 pi over 12. So then your equation of your asymptote, x is equal to 6 pi n plus 5 pi over 12. So these last few ones are just to help you find your domain, which helps you to find your equation of your asymptotes.